going to be the adding and subtracting with scientific notation. So let's get started with this one. This one could get a little bit more complicated. Let's start with the example, say 5.5 times 10 to the exponent 2 plus 7.6 times 10 to the exponent 3. Let's just start off with that first. So when we start with this one, we notice that these two numbers or exponents are different. So you cannot just add these 7.6 plus 5.5 and then add the exponents together, because if we were to write this in a long form, this would be 55 and a 0, and this would be 7600. That's 1, 2, 3. So when you add them, this answer will be what? 8150. So if you notice that if you were to add these two numbers, that would be actually just going to be what? 1213.1. So you can see that it actually is not the same. So in order to add your scientific notations together, these exponents, or the scientific notation exponents, have to be the same. So let's start off with that. So 5.5 times 10 to the 2 plus 7.6 times 10 to the 3. Well, this one is sort of easy to convert because we only have 2 and 3 exponents. But if you get larger ones, one technique is to factor. You're going to factor the exponent out of this addition question. So you're going to factor the exponent that is the lowest one, because it covers this one and this one. It's like the lowest common multiple kind of deal. So you're going to factor, let's say, 10 to the 2. So when you factor, basically you're just dividing this by this. You're dividing this by that as well. So since this 10 to the power of 2 is divided or factored by this 10 to the power of 2, you're just going to get 5.5, and then this will be just 1, be 10 to the power of 0, plus 7.6, and you're factoring this 10 to the power of 3 by 10 to the power of 2. So when you're factoring, basically, again, this is division. So it's 10 to the power of 3 factored or divided by 10 to the power of 2. You subtract the exponent, you get 10 to the power of 1. So this is 10 to the power of 1. You still have that here. Okay, so then that's still have this little factor on the outside. So the next step is now, because once you factor this, your exponent is a lot smaller. So you're going to just put this into the long standard form. So 7.6 times 10, which is 76, and then times 10 to the power of 2. So then, since now we don't have this scientific notation anymore, we can actually just add this. So 76 plus 5.5, that's going to be 81.5, and we still have this times 10 to the 2. This gives us 81.5 times 10 to the 2. So if you want to change this into decimal form, there's just going to be 81,500. Just 8150. So that's my answer. That's what initially that's what we calculated, right? So the key thing is it's factoring. That's always the tricky part. So if we do like another example, that's a little bit more tricky, like 10 to the power 4 plus 2.3 times 10 to the 7. So when you see something like this, you can't just add these numbers, because this exponent and this exponent, they're a lot different. So this is basically 6.3 with moving the decimals 4 times to the right. This one you have to move the decimal 7 times to the right. So in order to do this, we have to factor. So let's factor something. We're going to factor the exponent, or the scientific notation exponent, times 10 by the lowest common one. So the lowest common one is going to be 10 to the 4. We're going to take this out, and we're going to take this out by 10 to the power 4. Everything, all the decimal place will stay the same, so 6.3. So since this is since this is 10 to the power 4 divided by 10 to the 4, this is going to cancel into 1, so we don't need that. Plus 2.3, and this is going to be 10 to the power 7 divided by 10 to the 4. That's what happens when you factor again. So that leaves us with 10 to the power of 3. We subtract the exponent. So that gives us, don't forget this. So now after having this, it's a smaller exponent. So we're just going to go plus 2300. So you notice now it's a lot easier to do because our exponents are smaller. So this is going to be 2, 3, 0, and add these numbers together. So 6.3 times 10 to the 4. So that's how you solve this problem. Notice that this one is times 10 to the 7. It's a pretty big number. But once you sort of add this in, you can still see that it is times 10 to the 7 once we move the decimal place over. Okay, so if we want to change that, move this decimal place after the 2. So it'll be 2.3063 times 10. This will become to the power of 7. How come we change this to the 7? Because we move this decimal place 3 times to the left. By moving it 3 times to the left, we actually made this exponent larger because then we have to move more back to the right side. That's the little bit tricky part that you have to sort of wrap your head around, but give this a try. And when we're doing subtraction, is essentially the same thing. Don't forget to do the factoring first.